So we're asked to solve each equation right here. So going into the first example right here, really you can see there's an x right there that we want to solve for, but it's a little different than equations we solved for before, because if we're dealing with matrices in this equation, then with that capital letter X, it's really standing for a matrix, right? So if we're trying to find x, we really want to find what matrix we want right there. And of course it's going to have to be another 2 by 4 matrix, because that's the only way you can add two matrices together. So this would be a problem where you can kind of just, go about and figure it out. Like, okay, so 2 plus whatever's in the first spot of that matrix right there needs to be 9. So like obviously 7 is going to have to be the first number in your matrix for x. So you could go about it that way and get it easily accomplished in that regard. But I also want to show you the fact that, just like with numbers, how you can do the same thing to both sides of an equation to solve an equation, you can also do that right here. So if I were to actually just subtract this matrix right here, then of course you would get the 0 matrix and then basically just x alone on that side. So then to keep the equation balanced, I'd want to subtract the same matrix on this side of the equation to keep it balanced, and that actually is another way that you can then solve for x, because you get x alone then on that side at that point, and then you just have to take that matrix and subtract them. Be careful about that because you're subtracting, so you got to watch out for subtracting negatives and all that sort of stuff with your integer operations. So if we do 9 minus 2, you get 7. 1 minus negative 3, so there's a subtracting negative. You're actually going to add and get a positive 4. And then you would have your 6 minus 8 is negative 2, and then 5 minus 0 is 5, 0 minus 1 is negative 1, 6 minus 3 is 3, 11 minus 5 is 6, and 8 minus 8 is 0. So that would give you that, and of course if you wanted to test it, you could add that matrix with that matrix and make sure that it comes out to be what you want it to be there to solve for x. And so yeah, just in kind of a similar regard with an equation kind of like you're seeing right here, you can kind of do a similar sort of approach if you want to do like the same thing to both sides of the equation. So if you wanted to solve for matrix Z, then I guess you'd kind of want to add this matrix here to both sides first, and then you can just like divide by 3 or multiply by a third. So if I just add this matrix right here, then those are going to combine and just be 0, so you're just going to get 3 times Z on that side. So then if I now add to this side, 1 plus negative 4 is going to be negative 3, negative 2 plus 3 is positive 1, and 0 plus 1 is 1, and 5 plus 7 is 12. And then I can divide by 3, or equivalently just multiply by 1/3, and then that'll give you the Z matrix isolated. And so then if you 1/3 all of the elements inside of this matrix here, you're going to end up with a third of negative 3 is negative 1, 1/3 of 1 is 1/3, and 1/3 of 1 again is 1/3, and then 1/3 of 12 is 4, and then that gives you the value for matrix Z that's going to satisfy that equation.